Hi everyone, this is Yashasvi. I am a third year college student and I've recently cracked Google internship. I did a step internship in this summer, which is 2025, but I got a PPI and I'll be returning again in 2026 as a SUI intern at Google.
So hello guys, welcome to our lovely binary search pattern course lecture number 2. So guys, what happens is that generally these two problems, which is the first one is search in a rotated sorted array, and then the second problem is find minimum in rotated sorted array. There are multiple standard DSA sheets and DSA tutorials teaching these problems, but I see there is a core issue with all of them. They are just trying to teach you the algorithm that this is the problem, apply this binary search algorithm. They are not discussing why is this algorithm only working? Why is there no other algorithm working? What is the intuition? What is the logic? How could you come up with your own self? How could you come up with this algorithm on your own without any external help? How would you do a normal human based analytical thinking to come up with these algorithms? So these things are taught in a very non-intuitive way in other tutorials and videos. So what I will do is, rather than teaching you in the standard way, I will discuss with you what the problem actually is. I will open up the problem in front of you. I will show you some observations. And when you see those observations, guys, normal human solution would be clear to you. After you know the normal human solution, then I can slowly show you the actual efficient solution, which will come out from the normal human solution only. So let's start with the procedure. So guys, we are going to solve two problems and both the problems are actually same only. You will come to know about it during the middle of the session. So find, search in a rotated sorted array. So a sorted array is given to us, right? Which is left rotated as written in the question. So if I try to show you the question, let me show it to you in the best possible way. There is an integer array num sorted in ascending order with distinct values. Guys, all the values in the array are distinct. They are different. Prior to being passed to your function, nums is possibly left rotated at an unknown index. So I have to find a number in a sorted array, which is very easy to do. I can use binary search if you have watched lecture 1. But now the array is left rotated. So let me show you what is the meaning of left rotations which are going on. So if my array looks like this, let's say my array looks like this, okay? My array looks like this. We always start everything with the name of God, Ram Ram. So guys, see my array looks like this, okay? 0, 1, 2, 3, 4, 5, 6, 7. This is a perfectly sorted array in ascending order, no problem. But what is left rotation 1? Left rotation 1 means this 7 comes ahead by one step. So it would look like 7, 0, 1, 2, 3, 4, 5, 6. Just a left rotation, okay? Then left rotation 2. It would look like now 6 will go ahead. So 6, 7. Left rotation 3. 5 would go ahead. 5, 6, 7, 0, 1, 2, 3, 4. Left rotation 4. It would look like 4, 5, 6, 7, 0, 1, 2, 3. Guys, can you do an observation? This is the human way of thinking. Can you see this 0 was here, then it's going here, right, one step, and in the end, 0 will be here. Okay. In which left rotation? Most probably this is left rotation 4. Then there will be left rotation 5, left rotation 6, left rotation 7. Okay, in left rotation 5, 3 will be ahead. In left rotation 6, 2 will be ahead. In left rotation 7, 1 will be ahead. So in left rotation 7, it will be 1, 2, 3, 4, 5, 6, 7, 0. Okay. So guys, left rotation is nothing but what? If I pick up left rotation 3, just try to see what is happening. The left part is sorted 5, 6, 7, and this right part is also sorted 0, 1, 2, 3, 4. So guys, our array has been divided in two sorted parts. If this is the sorted array, I will not be always given a sorted array in the input. I will either be given L1 in the input or L2, L3, L4, L5, L6, L7. I have not shown L5, L6 because of the space constraint, but I hope you know what they are. So I will be given a left rotated array. So what is a left rotated array? Left rotated array is nothing but an array created by joining two sorted arrays. That's it. So L3, let's talk about L3. L3, only L3, okay? So you know now in L1 this goes at L2, L3, yeah. 5, 6, 7, 0, 1, 2, 3, 4. So guys, when you look at this now, only two things should run in your mind. This is the left sorted part, and this is the right sorted part. You see now, this thing is actually true, beta. Left sorted part and right sorted part. So if I try to make the diagram, how does that look like? If I try to make the diagram for you, 5, 6, 7, it is increasing like this, 5, 6, 7, then it comes down like this, 0, 1, 2, 3, 4, like this. So it goes up, then it goes down, okay, it goes down like this. So there is this valley point. So it is like this, goes up, a valley, then goes up again. So we just have to find the valley point. If you are able to find the valley point, guys, this is a normal human way of thinking. See, I did not do anything special. I just showed you that any left rotated array, or for the matter, you can even call it right rotated array, because right rotations will also generate similar kind of arrays, okay? So any left rotated array or right rotated array, in the question they have perfectly called it as left rotated. A rotated array is nothing but an array created of two sorted arrays, left sorted part and right sorted part. So for left rotation 3, 5, 6, 7 is in the left part, 0, 1, 2, 3, 4 is in the right part. So guys, if you know the target value, then you just need to check target value is coming under the left part or it is coming under the right part. If it is coming under the left part, you will just do binary search on this part and you will find out where the target is coming. And if the target value is coming in the right part, then do binary search in this range and find out where the target is coming. So it's so easy. Let's say L4 is given to you, okay? So it looks like, like else for L1, 7 was there, 6, 7, L2, L3 was like this, so L4, okay. Fourth left rotation would look like what? 4, 5, 6, 7, 0, 1, 2, 3, okay? Let's say the target value is 5. You want to binary search and find where is 5 coming. Very easy, don't worry, it's really easy. First step is figure out the left part and right part. Figure out the left part and the right part. So left part plus right part. So very easy. You see, this is the left part. In left part, the minimum number is 4, maximum number is 7. In right part, minimum number is 0, maximum number is 3. Now you only apply common sense. 5. 5 is coming in 4 to 7 or 0 to 3. For the left part, you know L1, which is the minimum value of the left part, and you know the R1, left part, which is the rightmost boundary of the right part. L2, R2. So you can just write a simple if condition and check. Is target greater than equal to L1 and less than equal to R1? If our target is greater than equal to L1 and target is less than equal to R1, then guys, it's simple. Target is just coming under the left part. If target is greater than equal to L2, similarly, and less than equal to R2, target is coming under the right part. Here, our target is coming under the part from 4 to 7. So now what will I do? In step 1, I have figured out that it is coming under the left part. Left part is from 4 to 7. Now what will I do in steps 2? Just do binary search. Do binary search in the left part. This is a common human way of thinking. The left, whatever array is given to us, we can divide it into two parts. Divide in the left part, right part. Now find out your target is coming under the left part or the right part. If it is coming under the left part, left sorted array, now do binary search and find where the number is coming under the left part. If it is coming under right part, do binary search and find out where this number is coming under the right part. That's it. So now I will do binary search from 4 to 7. So guys, you know that standard binary search algorithm. 4, 5, 6, 7 is the only array you have. This is the low index. This is the high index. You now can do binary search and find the position of 5 in this. So it will take log n time. So guys, this problem is totally solved. Step 2 is totally clear. Once you know it is the left range, you do binary search in that left range. If you know the target is in right range, do binary search in that right range, L2 to R2 or L1 to R1 if it is in left range. For right range, L2 to R2. But guys, L1, step 1, there is something which we did not figure out. How will you figure out which is the left part and right part? Step 2 is clear to us. We will not discuss about it again. But how do we figure out which is the left part and right part? You can do it in O of n time, right? That is not a big deal. You can travel the array from left to right. Wherever you see the most minimum element of the array, that is the valley point. See, array looks like this, right? It goes up, then it goes down, then it goes up. So this valley point is the breaking point, right? This valley point is the breaking point. This valley point is nothing but the breaking point. How do you find the breaking point? O of n method is very simple. Travel this array and find like this. These are the indices of the array, right? Travel this array and just find out by traveling this lovely array, just find out very simple thing. Just find out one lovely thing for me. What is that lovely thing? Where is minimum element coming? You can travel from left to right in O of n time, and index number 4 is the minimum point. So you know if index 4 is the minimum point, it means everything from 4 to this is called as the right part, and everything before index 4 is nothing but the left part. So guys, can you see everything is happening logical? I did not say any solution. So what is actually happening? Enjoyment, lots of enjoyment is happening. You travel the array in O of n time, you figure out the breaking valley point, the minimum value. Everything from minimum value towards n minus 1 is the right part, and everything before that minimum value is the left sorted part, because the array is made in that way. Array is always increasing, then a down point, then increases. It is always like that, okay? So in O of n time, you can find the left part and right part, and then you can do the step 2 in O of log n time. But guys, what is the total time it takes? It takes O of n plus log n time, which is not very efficient because you're traveling the whole array at least one time. Now, can you optimize the step 1 to O of log n? Can you optimize the step 1 to O of log n? Can you optimize the step 1 to O of log n? Yes, you can. You are now trying to find the minimum element of this thing, okay? You're trying to find the minimum element of this left rotated array, or you can call it as right rotated array. In the end, I will show you left rotated array. If there is a left rotated array, it can also be generated by some number of right rotations as well. So nothing to fear about. So how can you find the valley point by doing binary search? Now this is really complicated. Yes, it is. So how to do that? Let's think about it. Let's take a bigger rotation, right? Let's take L6. Yeah, L6. Let's take L6. 4, 5. So 2, 3, 4, 5, 6, 7, 0, 1, 2. Okay. So this is a left rotation. There were many left rotations in the example as well. If I try to show you, yeah, 4, 5, 6, 7, 0, 1, 2. Okay. Yeah. So let's go. So guys, Ram Ram. Now this is L6. You have to find the minimum element. You have to find which is the minimum element. You have to find its index also. We know what is its index. We can see that because we have eyes, but how will the algorithm find out? We know that the answer is 6. How to find it out? Do binary search. Left value, right value. Okay, guys. L is pointing here, R is pointing here. Complete full focus, full focus. L is pointing to 0, R is pointing to 8. What is the mid value? You know, you calculate mid. So 0 plus 8 by 2, 4. So this is the mid value. Our target is the minimum element. The mid value is what? Let's see what is the mid value. Mid value is 6. Mid value is 6. Directly compare 6 with the last element. You got your mid value as 6. Compare 6 with the last value. If 6 was less than equal to 2, if 6 was less than equal to 2, it means 6 is in the right part. But 6 is not less than equal to 2. If your middle part which you currently are at, if it is bigger than this, it means 6 is in the left part. 6 is in the left part. 6 is in the left part. 6 is in which part? Left part. Okay. So you're trying to find the pivot. You're trying to find the value. Okay. So I can show it to you with multiple examples. Okay. For example, let's say instead of 6, your mid was 1. Your mid was what? Let's say your mid was hypothetically this guy. 1. Okay. Now compare this 1 with this last value. 1 is less than equal to 2. If your current value is less than equal to 2, it means your 1 is in the right part. 1 is in the right sorted part. If the current value is less than equal to last value, it means current value till the last value is in sorted direction. Is it in sorted way? It is the right part. It is the right part. This is the biggest observation which solves the whole problem. Whenever you are at a mid value, compare that mid value with the last value. If that last value is less than equal to the current value, if that last value is less than equal to our mid value, it means everything from here till the end was sorted. It means we are in the right part. But if that mid value is not it is not greater than this, if that mid value is not greater than us, it means we are in the left part and that is the right part. So for 6, what happens? You see that 6 is greater than 2. It means 6 is in which part? 6 is in left part. 6 is in left part. So 6 is in left part. The only deduction you can do by this mid is that 6 is in the left part. 6 is in the left part. 6 is in the left part. Now the things are very easy. We know that the minimum number will always be in the right part. So 6 is in the left part. 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 So the minimum will be where? On the right hand side. 6 is in the left part. So now how will I update my L? Earlier my L was what? 0. Now my L will be mid plus 1. Earlier my L was pointing to 0. Now my L will point to this guy. So now I will be searching in this range 7012. Why? I know my current guy. Is in the left part. It means the minimum 0 guy must be on the right part. And for right part, I need to go in the right hand side. That's why L equal to mid plus 1. Also, one more thing you should always keep check of while trying to find the pivot, okay, which is very, very important. This left right thing, I am sure it is getting clear to you guys, okay? Let's take some, before I take some other example, if you directly hit mid as this now, always be very careful, okay? You are hitting, let's say, mid directly to 0, okay? Any other number you check now, they will always be like this. The mid minus 1 value will always be strictly less than mid, and the mid value will always be strictly less than mid plus 1. This is true for all the values except 7 and 0, because when you are at 0 it looks like this, you are mid, so you have to add a check condition. If the left value is also bigger than you, if mid minus 1 is also bigger than you, and mid plus 1 is also bigger than you can see here 0, mid minus 1 7 is bigger, and mid plus 1 1 is also bigger, then you are indeed the minimum value, because this valley thing can happen only one time. And special condition for this 7 also, if the left hand value, this is mid, left guy is small or left guy does not exist, that's okay. But if the right hand side guy is smaller than you, it means you are a peak. So you can just declare, yeah, 7 is the peak. It means 0 must be on the right hand side of 7. So guys, apart from the conditions I told you, now you should, how will you know whether your current guy is the right guy or not? How will you know that? To know whether the current guy is the right guy or not, what you can do is you can check these things. By checking these things, you can come to know, is your number 7 or is your number 0? If your number is 7, if your number is indeed 7, then just go one side on the right hand side and the job is done. Okay. And we will never be doing this algorithm on this type of array. 0, 1, 2, 3, 4, 5, 6, 7. We will never be doing here. Why? Because we can check in the start only that a of 0 is less than equal to a of 7. It means it is already sorted. So you can just do a normal binary search in this full range from L to R. Okay. So whenever there is a 7, there will be one space on the right hand side. So if you hit a 7, this is the answer. If you hit a 0, you know na, 0 condition, it always look like this. Left guy bigger than you, right guy also bigger than you. Okay, and we are at the mid. Okay, this much is clear to you people. So guys, that's it. What is the algorithm? Algorithm is pretty simple. As soon as you get a midpoint, check, is it is mid minus 1 mid plus 1 greater than us? Then yes, that's the answer. Is mid plus 1 less than me? Then that guy is the answer. And if none of them is happening, it means this is mid minus 1 generally, and this is mid plus 1. So I am a part of what? I am a part of sorted array. So I should figure out whether I am in the left sorted array or I am in the right sorted array. If I am in the left sorted array, I will try to move my pointer to right. And if in my right sorted array, if I'm in the right sorted array, so let's say my number is let's say 3, okay, and this is 4, and this is 2, and this is my mid, and I know that this thing is in the right sorted array. So obviously I will try to go to left because the minimum value 0 or minimum will be on the left hand side, right? But if I'm in the left sorted array, I will try to go towards right hand side. Like if I want to show, I can show you example like this: 5, 6, 7, 0, 1, 2, 3, 4. Okay. Let's say somehow my mid is coming here. So my mid is coming here 3. I will do what? I will check. First of all, I will check, yes, this is a part of a sorted array because it is going like this. And 3 is less than equal to 4. 3 is less than equal to 4. It means 3 is in right sorted array. If 3 was not less than equal to 4, 3 would be in left. This is right. So this is my mid. Okay. Then what will be, let's say this was my L. It cannot be your L, but still let's just take example L, R, and this was the mid. So this is the mid, you know that the answer is on the left hand side. So what will you do? You will declare your R as mid minus 1, and now you will search in this range 7012. For this L and this R, this could not be the mid. I'm just taking an example. Okay. So guys, now let's go through the C++, Java, and Python codes. Like that, what are the total number of operations? It is O of 2 log n, because we are doing step 1 to find the minimum element. Once we know the minimum element, guys, we know the left part, we know the right part. We can check target is in the left part or right part, and we can do binary search in that part in again log n time for step 2. And in 2 log n time, it is getting done. And 2 is a constant, so you can say that it is log n complexity. This is the human way of doing. Now that you know the human way of doing, now we can go towards the optimized approach where we don't have to run 2 binary searches. Now, first, let's check the code of the 2 binary searches. It's lovely and very, very cute. So let's do that. Ram Ram. Seems I need lots of water and hydration today. Anyways, now, guys, you can see the possible rotations. I tried to make here 0, 1, 2, 3, 4, 5, 6, 7. Here the 0 is going on the left hand side. Okay, see guys, there are multiple ways. In the video, I showed you this 7 gone front, 6 7 gone front, and things like that. Okay, so it's possible, like the I am trying to, these I would call them as right rotations. Okay, or wait, 0 1 2 3 4 5 6 7. I took this and I put it there. Okay, so that was left rotation. Yeah, this I can call it as right rotations. Okay, but so it does not matter left rotation or right rotation, you get the idea. No matter what type of rotations I show you, they are just made up of two sorted arrays. First part, second part. Left part, right part. Left part, right part. Left part, right part. So you can read all this material, try to understand it in best way possible now. So guys, we have already solved the second problem. Second problem was what? Second problem we can just solve in step 1 na, log n time, find the minimum in rotated sorted array, the pivot element that we do in step 1, and in step 2 we find the target element because we know the left part and right part, right? So find minimum in rotated sorted array. This problem has already been solved. Okay, you can see such a nice thing it is. This problem has already been solved. Okay, so guys, now let's check the C++, Java and Python codes for search in rotated array. Okay, so here we are in two binary searches. Let's check the C++ code and then let's think how we can do it in just one iteration. Okay, then there are some follow-ups which are asked in Amazon SD internship interview. We will go through them also. Okay, we will go through them also. Okay, so first let's go through the C++ code. Okay, so hopefully things become visible here, like copy to code editor. Okay, so guys, see what is happening in the C++ code. If n is equal to 1, guys, I just directly return that element na, a of 0, right, without any stress. Okay, if n equal to 2, I just check the two elements. If any is target, just do that, because these are very small ranges and you should not do too much calculation in those small ranges. If you want, you can, but it can get complicated. Okay, now guys, I'm trying to find that valley point. Low is 0, high is this, valley is -1, L1 R1 for the left sorted range, which I will try to find, L2 R2 right sorted range. If A of low is less than equal to A of high, it means the full array is already sorted. So L1, only one range, one sorted range is there in that case. So L1 low, R1 high, L2 R2 does not exist. But if this is not the case, it means there are two sorted arrays for sure. So in this else case, it means two sorted arrays exist for sure. Okay, okay, clear. So guys, yeah, I will go through low and mid. Okay, now I'm checking some things. So mid -1 should be greater than equal to 0, and if my mid -1 is greater than me, okay, so if this is mid and mid -1 is bigger, so it means this is the valley point here, right? So this is the smaller point, we found our valley. So this is our valley point. Okay, but if that is not happening, then this is the mid, this is the mid +1. Okay, so if I am bigger, I am okay. Okay, so I am bigger than mid +1. It means it is the peak point. Mid +1 is the valley in that case. I am 7 and this is 0. So yeah. But if none of those cases are happening, then it's very easy. Those cases I covered. Now it is sure that it is, see, this case is not happening and this case is also not happening. It means it is this. We are in a sorted array. So just check with the last element. If our current element is less than equal to last element, it means we are in right sorted array. If you're in right sorted array, it means you need to go to left. So that's why high equal to mid -1. But if it is not, it means we are in the left sorted array. We need to go to the right. So low equal to mid +1. Done. Valley found out. So L1 will be 0. R1 will be valley -1. R2, L2 will be valley, and then R2 will be n -1. So left part, right part figured out. This is the left part. This is the right part. Now just check now your target is where. So if target is greater than equal to A of L1 and less than equal to A of R1, then L1 R1 is the range in which we have to find the target. Or if target is greater than equal to A of L2 and less than equal to A of R2, then L2 R2 is the point where we have to find it, right? If L equal to -1, it means something happened and we could not find anything, so -1. Okay, when that case occurs, we don't need to think much about that. Now guys, just do a simple binary search in your correct LR range and find the number L plus R. If this is target this, if A of mid greater than target R equal to mid -1, you know that thing, right? That L equal to mid +1. You know these basic things. You're very smart for that. And guys, that's it. Now let's check the Java and Python codes, which are very much similar. Okay, Ram Ram. So Java code and Python code. Then let's think how can we do it in just one iteration. Okay, so guys, Java code is very much similar. Like, you don't need to worry, everything is same. Okay, see, n equal to 1 case, n equal to 2 case, low, high, valley, l1, r1, l2, r2, while conditions, all the things are exactly the same. Like, the syntax of C++ Java is so same, there is literally no difference. Okay, you can just check it out. And yeah, this fire emoji, sorry for that. Now let's check the Python code. Python code is also very simple, like L1, R1, L2, R2. See, the basic computations in C++, Java, Python, the codes are very simple. When you're just writing while and if else, it's just the same. Like, even a Python guy can understand the C++ guy code, okay? Yes, in binary search questions, the C++ guy can understand Python guy codes, and Python guy can understand Java and C++ codes. So you can see n equal to 1, n equal to 2 case. Those can be omitted. Huh? If someone is able to omit them, let me know in the comments. We will update that. Okay. So L1, R1, L2, R2, you understood. A of low, this thing you know, this thing you know, right? Made -1 conditions and all. L1, R1, L2, R2, and that's it. Okay. Now, how to do it in just one binary search? And if you do it in one binary search, guys, now it will become O of log n. Okay. Follow-ups were asked in Amazon SD internship interview. Before we go to the follow-ups, think about how can you do it in just one binary search. Okay. Mhm. We are trying to find some element, right? So let's try out. Let's see what happens actually. Okay, so let's take some left sort rotated sorted area and right rotated sorted area. Okay. So let's say it is 5, 6, 7, 0, 1, 2, 3, 4. Okay. Let's say the target element is 3. You are trying to find 3. Where is 3? Okay. So what you will do? This is your low. This is your high. Okay. What is your mid? My mid will be 0, 1, 2, 3, 4. This. First thing which I can do is I can check whether this part is in the left part or the right part. So directly check 1 with 4. Na? Okay, I checked 1 with 4. 1 is less than equal to 4. 1 is in the left part. 1 is in the left part without figuring out the pivot. I just know that 1 is in the left part. I just know 1 is in the left part. 1 is in what? Left part. I don't know this point, but I do know that the end point is n minus 1. I know 1 is in the left part. 1 is in the left part. So I do know that everything from 1 to 4 is in what? Left part. So I will just check target. Is target coming in this range or not? Yes, target is coming in this range. So I just need to do binary search in this range. And now my low should be, because target is coming in 1, 2, 4, 3 is coming in 1, 2, 4. Low should go 1 point ahead and low should point to 2. So low should just become mid plus 1. So guys, problem solved, by God. When you are at mid, just check. Are you in the left part? Are you in the left part? Are you in the left part? Yes. I know everything from now till the end. I know it has been ingrained in your brain. Is in the left part. Is the target is also in this part? Yes. Low equal to mid plus 1. Search in that range. Now let's think what would happen if target was 0, let's say. In that case, what would you do? This is again low. This is again high. This is your mid. You know one thing. You know that we are in the left part now. You know we are in the left part. And you know that this is the right part. Okay. You know this 1 is in the left part. You know there is this 4 in the left part. And you know that this right part starts here and these numbers are bigger than 4. You know that this is the left part, and the left part, you don't know the starting number, but you know the last number is as big as 4. And here in the right part, all the numbers are greater than 4. All the numbers are greater than 4 because left's rotated now. You want a number 0 which is less than my current number. You want a number which is less than my current number. It means it could only be on the left hand side. So now I will update my high to mid minus 1 because it could only be in the left hand side. So my high will be updated to this 0. So I will be searching in 5670. Why? Earlier I was searching from, this was the low, this was the high. Now I know I'm in the left part, and I also know that I want a number smaller than this. So it means the target number is, sorry, I know that I'm in the right part. Sorry, yeah, we call it as the right part. If I called it as the left part in the video back, don't get confused. I know I'm in the right part. I know I'm in the right part. Okay, right sorted part. If the number is coming in this range, go in that range towards the right hand side and search it out. But if the number is lesser than this, but it is still in our range only, it is surely in our range because the left part is having all numbers greater than 4. And we want a number less than 1. So go on the left hand side and update your high as mid -1. So it will be searching from 5670. Okay. Now what would happen if, now it's interesting. If target was 5, this would be low, this would be high, and this would be mid. You know that, yeah, 1 is in the left hand side part. You can just check this, na? Yeah, it is in the left hand side part. Okay, great, man. So you know that everything from 1 to 4 is in the, sorry, this is called as the right sorted part. This is called as the right sorted part. You know that 1 to 4 is in the right sorted part. You know that the 4 is the largest number here. Okay. Okay, sir. But you see, target is even bigger than 4. It means target comes under left part. For the right part, the largest number is 4. And you want a guy bigger than that. It means that guy is on the left part. It means you should search on the left part. So I will again update my high as mid -1 and I will search for 5670 here. Okay. Now let's take another case where let's say my low was this. Okay. My high was this and my mid was 7. Okay. So how would you know that this is, first of all, you would check 7 less than equal to 4. No, it means it is on the right hand side. It is on the right hand side. Now you would check what are you searching. Let's say your target was, let's say it was 6. So you know this is 5. You know that 5 to 7. You know that this current number and this guy are coming under left sorted part and they are bigger. You know that also. If this 6 is coming under this range, you will just do binary search here. So your high will be now mid -1, and instead of 5 to 1, you will search in 5 to 6. Okay, this will become m -1, right? But if your target was, let's say, 0, it like, you know that this is in the right hand side part now. So you know that 0 is not in our part possible because our smallest value is 5 and our current value is 7. So we are in the left sorted part. We don't know how much it is, but 5 is the smallest number and we want even smaller than that. It means we need to go to the right sorted part. So my mid would extend to, you know, sorry, high would become mid +1 and we would be searching in this range 0 to 1 for that. So like this, you can always make if else conditions and the job is done, guys. So lovely, we did it in just one binary search iteration. So let's check now the codes. So guys, follow-up questions are very easy. Okay, they were asked in Amazon SD internship interview. So I try to include the recent company interview questions also, so that my students are fully prepared and then they can crack the highest value, offers. So C++ code. Okay. So guys, now in a very lovely manner, let's check the C++ code. Okay. So guys, for the C++ code, you can see low, high, right? If you found the value, be very happy. Else, just check whether you are in the right part or you are in the left part. If current is less than equal to this, we are in the right part or we are in the left part. If you are in the right part, simple condition, guys. If you are in the right part, if your target is also less than equal to that, then you can just apply normal binary search conditions. Because target is less than equal to an -1 means target is in that part only. So if current less than target this, current greater than target this, normal binary search things. Okay. But if target is out of this range, it means you need to go to left sorted part, means high equal to mid -1. You go towards the left. And guys, if you are in the left sorted part, if your target is greater than equal to the first element of the left part, it means your target is in the left part only. You can now apply normal binary search there. If current less than target this, if current this. Okay. But if target is lesser than 5 also, it means target is in the right part, so you need to go towards the right, low equal to mid plus 1. Such a nice lovely algorithm, my goodness. So C++, Java, Python codes are very similar. So I'm not showing you the Java and Python codes. You can go through the Java and Python codes of the same thing. Okay, here the links are this document and everything will be provided. Search in rotated sorted array 33 and find minimum in rotated sorted array 153. Both have been taught here. Now, guys, how many times the array was rotated? If this question is asked to you in Amazon SD internship interview, what you will say? You will just ask them what is the definition of left rotated sorted array or right rotated sorted array. Is it taking the element from here and putting it towards the left? So in that case, you can easily find out how many times it is left rotated. Know the pivot position. The pivot position is nothing but the number of times it was left rotated. Kth smallest element also very simple. If you know the pivot position, from 0 till that, you know there are how many elements, so you can figure out how many to where will be the kth element. All these are homework for you. How to find how many times the array was rotated, let's say left rotated or right rotated. First ask the definition to the interviewer. Then with the help of pivot element, you can tell how many times the array was rotated. How to find the kth smallest element, homework. Write the answers of this with the timestamp in the comments to let me know that you were able to reach till here. What if there were duplicates? The average case solution would be O of log n, but the worst case can go to O of n, which we will discuss in the upcoming next video. Hopefully you guys like this video. Ram Ram. Ram Ram.